Okay students, welcome to my channel once again. This is Venkatesh, your drawing faculty. Okay, so in our last class we discussed about ellipse and its nomenclature, hyperbola, how they are formed, and the conic sections, and the eccentricity concept, the conic concept, and hyperbola and parabola, what are the types in it. Okay, now today in this lecture I am going to tell you about there are certain similarities between ellipse and hyperbola. So that's why I am going to tell you about these similarities. First of all, ellipse will follows the equation x minus h whole square by a square plus y minus k whole square by b square. Okay, so now here if a is greater than or equal to b, or greater, not greater than or equal to, just a is greater than b, then what will happen is you will get a horizontal ellipse. You will get a horizontal ellipse. Why? Because of, see, this is the 2a. This is the 2a. All these are mathematical related concepts, but you might get a, there is a chance of getting a question regarding this also. So that's why I'm just telling you. And this is 2b. Okay. And from here to here it is known as linear eccentricity. Okay, x minus h whole square by a square plus y minus k whole square by b square is equals to 1. This is the equation, governing equation. Okay, so now if what if b is greater than a? Nothing, just simply what will happen is this will get reverse. You will get a vertical ellipse. You will get a vertical ellipse. Okay, so this is about b is greater than a. So what will be the particular equation for hyperbola? It will be x minus by a square minus y minus k whole square by b square is equals to 1. See, this is plus and this is minus. Okay, so this is here. And one more thing is hyperbola is like this. Okay, it will be the, here it will be the directrix, here it will be the directrix. Okay, so next, sir, then what is the nature of this ellipse? If you consider, see, this is the f2 and this is the f1. If you consider any point here, the sum of distances with focus, the sum of distances with focus for the normal, for the point which is located on the ellipse is always constant. Okay, that means, so if you consider here pf1 plus pf2 is, let us say if pf1 plus pf2 is equal to some x you got, even if you consider point here, let us say this is as p1, pf1 plus pf2, here p1 f1 plus p1 f2 also will be x. Okay, if you consider here p2, then p2 f1 plus p2 f2 is equal to also x. Okay, so if you consider any point, the sum of its distances with foci points will be is equal to constant. So the sum is equal to constant. But here in hyperbola it is difference, pf1 minus pf2 is equals to constant. Suppose if you consider any point here and f1 f2 will be here, f1 and this is the f2 and this is the v1 and this is the v2. Okay, and the pf1 minus pf2, the difference between pf1, the pf1 minus pf2 is equals to constant. Even if you consider another curvature here p1, still here also p1 f1 minus p1 f2 will be is equal to x. This is also will be equal to x. So the values of this equation will be same as considered. Okay, so there will be no changes. Okay, so now we got 2 points here, x minus h whole square by a square plus y minus k whole square by b square is equal to 1, and here x minus h whole square by a square minus y minus k whole square by b square equals to 1. and here Pf1 plus Pf2 is equal to constant, and there Pf1 minus Pf2 is equal to constant. Okay, and the next third point is, see, suppose this is the ellipse. Okay, this is known as largest conjugate axis. This is known as largest conjugate axis. The major axis is known as largest conjugate axis, and this is known as the smallest conjugate axis. This is known as the smallest conjugate axis. This is V1, V2, and this is F1, F2, and this is V. Okay, so now here in hyperbola, okay, see, in hyperbola, this is the V1 and this is the V2, and F1 will be here and F2 will be here. Okay, and there is no major and minor axis. There is only one and only axis, that is called it as transverse axis. That is called it as transverse axis V1, V2. Here this is conjugate axis V1, V2, and you have, this is the largest one, and the smallest one is, smallest conjugate axis is this one. This is called as V1 dash, V2 dash, V1 dash, V2 dash. Okay, this is the, I mean, the co-vertices, the distance of co-vertices is known as smallest conjugate axis. Distance of co-vertices, and the distance of vertices will be largest conjugate axis. Okay, so now here there are no conjugate axis. Conjugate axis concept is not there in hyperbola. There is only one axis, one and only axis, and that is called it as transverse axis. It is called it as transverse axis. Okay, and here I told you x minus h whole square by a square plus y minus k whole square by b square is equal to 1. Here it is always a should not be equal to b, then only the concept of ellipse will come. What if a is equal to b? Either in here or here. If it comes a is equal to b, in hyperbola also if a is equal to b, see, if there is a is equal to b, there is no concept of these curvatures. If a is equal to b for this expression, then you will get a circle. Then you will get a circle. Okay, so there is no concept. Okay, there is no concept. Okay, so there is no concept of ellipse and hyperbola. Okay, so now the next point. Okay, what is the next point? And the next point is linear eccentricity. Linear eccentricity. For both it is common, c by a. For both it is common, c by a. So what is this c? This c is nothing but square root of a square minus b square by a square. A square minus b square by a square. Here it is nothing but c is equal to square, sorry, it's a square minus b square only. It is c is equal to a square plus b square. C is equal to a square plus b square. Okay, this is linear eccentricity. These all comes from mathematical terms. These are all mathematical equations. Okay, but there might be a chance of asking a question, so that's why I'm just keep giving you. And next, eccentricity is equal to, and you can write it in two ways in hyperbola. Okay, what it is? The ratio of distances of foci and the distances of between directrix. O1, O2 means directrices. This is O1 and this is O2. Here also E is equal to F1, F2 by O1, O2. Here the distance of F1, F2 is smaller than, see here, the F1, F2 is this much, but the O1, O2 is this much. F1, F2 is less than that of O1, O2 in ellipse. But in hyperbola, see, this is the directrices. O1, O2 is less than that of F1, F2 here in hyperbola. Okay, so if you consider, yeah, lesser one divided by bigger one. So you will get obviously less than that of 1 as E. Here also it is bigger one divided by smaller one, you will get eccentricity more than that of 1. Okay, so this is how it should be. Okay, so here if E is equal to C by A, then what will happen? It's square root of 1 minus B square by A square. Here it will be, if you simplify, you will get in E, in position of E, what you will get is square root of 1 plus B square by A square. These are the important formulas. Okay, please mind it. Please mind it. Okay, after completion of this specific class, I will prepare certain questions. And we will try to solve all those questions. There will be one practice session, especially for this, especially on this particular concept with previous year question paper questions. Okay, so the next topic is parabola. Okay, in parabola there is not much. Actually, you know, I already discussed about parabola. See, this is parabola. Okay, and this is the directrix. Here it will be another directrix. This is O1 and this will be the O2, and this is V1 and this is V2. Okay, and here it will be F1 and here it will be F2. Okay, so this is how parabola looks like. Okay, and here for this the equation will be y square is equal to 4ax. Okay, while you are drawing offset methods, you will get to know what about this equation. Y square is equal to 4ax. You might all of you might have gone through this subject, already come across with this all types of equations and all these things, but this is just like a brush up. Okay, so next, the length of the lattice rectum. Next one is length of lattice rectum. You know what is lattice rectum? The double ordinate which is passing through focus is nothing but the lattice rectum, and it is 4a, and it is, the value is 4a or 4b. If you consider this one as b, we always consider this one as b, no? So that's why we will take it as b. That means nothing but this. Okay, and here for parabola there will be asymptotes, and for hyperbola also there will be asymptotes, but for parabola the asymptotes are parallel with each other. The asymptotes are parallel with each other. In parabola, asymptotes are parallel, but in hyperbola, asymptotes are perpendicular. That means 90 degrees inclination will be there. Okay, and in parabola we have several methods. Okay, and apart from this you have so many things, and this is called it as, the entire thing will call it as abscissa. Of course we already come across with, but in parabola there is much about to discuss. Okay, so this is parabola. Okay, so now I'm going to discuss about the different methods to draw ellipse. Okay, it's not about ellipse actually, different methods to draw conics. In conics there are several types. One is circle and ellipse, parabola and hyperbola. We are not going to draw any circle. Why? Because of, you know how to draw the circle and it is, but for the ellipse we need to know about ellipse. Okay, so what are the different methods? First one is, you all of come across with this. First one is eccentricity method. First one is eccentricity method. You know, one directrix will be there, eccentricity E, they will give you eccentricity E, and the distance between V and F, they will be giving you the distance between V and F. Okay, and then what you will do is, from F you will draw a line, and from V you will rotate this one, there will be a point. Okay, next what you will do, you will divide the space here. From this, with the help of similar triangles principle, you will be able to draw ellipse there. Okay, this is eccentricity method. And for parabola, hyperbola also, the eccentricity method is same as it is going to consider. It follows both hyperbola and parabola follows similar triangles principle only in eccentricity method. Okay, so there is nothing much to consider about eccentricity method, as we all know. Okay, but concentric circles method, this is important. Concentric circles method. Okay, so in concentric circles method, what we will do, usually there will be two circles. Okay, there will be two circles which are sharing same center point. Circles which shares same center point or same origin. Okay, that is, those are called it as concentric circles. So you can have a doubt. What if two circles are not sharing same center? The circles will be like this. What will happen? What those type of circles will call it as? Those type of circles will call it as, if not eccentric circles. If not eccentric circles. Okay, and this depends upon the polar equation of ellipse. This depends upon the polar equation of ellipse. So what is this polar equation of ellipse? You all might know about the equation of ellipse, x square by a square plus y square by b square is equal to 1. Okay, and what will happen is, in polar equation of ellipse you will get x square by a square cos square theta plus y square by b square sin square theta is equals to 1. So how it came? Who proposed this? I will tell you. Who proposed this is Mr. De La Haye. Mr. De La Haye. Okay, and here what we will do is, why we need to use cos square and sin square theta, and you can ask me, so what about this x minus h whole square by a square plus y minus k whole square by b square? Okay, but we always consider the ellipse origin is center point. So if the ellipse origin is center point and this is the origin, we don't consider h and k values. That's why I took x square by a square cos square theta plus y square by b square sin square theta. You don't need to consider h and k. You will get all these things in your mathematics. Okay, Mr. De La Haye proposed this, and sir, how I got cos square theta and sin square theta? See, this is one circle and this is one circle. What happened is, for x, see, suppose to draw concentric circles method, what you will do is, you will divide this two circles into equal number of parts. If you are dividing this one into equal number of parts like this, what will happen? If you resolve vertical forces, you will get b sin theta. If you resolve horizontal forces, you will get a cos theta. That's why you got cos theta and sin theta as in denominator. Okay, this is the concentric circles method, and this was proposed by Mr. De La Haye. It follows the principle of polar equation of ellipse. The equation of ellipse is this: x square by a square cos square theta plus y square by b square sin square theta. It's very, very important. This is about concentric circles method. And the next one is pin string method. Next one is pin string method. Pin string method is nothing but the Gardner's method. It is also called as Gardner's method. In this Gardner's method, what we do is, we will fix 2 points like F1 and F2. Like F1 and F2, we will fix 2 points. Okay. Then what we will do is, we will join one thread like this with P. Okay, by fixing F1 and F2, we will rotate P. So what will happen? This P will rotate like this, and the locus of P will produce an ellipse. This is how the pin string method follows. Okay, next, oblong method. Oblong method will be drawn when the major and minor axis are the conjugate axis of the ellipse are given. The largest conjugate axis and the smallest conjugate axis are given. Then you will use oblong method. So apart from this, are there any? Yes, we have. Another one is fifth one, Trammell Archimedes. Trammell Archimedes principle. This is proposed by Mr. Archimedes. Okay. And in oblong method, you have two. One is rectangular method. Another one is parallelogram method. If you have any doubt how to draw this how to draw ellipse in this particular methods, I will give all those links in description. Why? Because of in my channel I already discussed. I'm already running an academic channel which is regarding to especially engineering drawing. There I already come across with these concepts, so I will give you links of those videos. But the thing is, in all those links, all the videos are done in my regional native language Telugu. Okay, so might Telangana and Andhra people can make better utilization of it. Okay, so apart from Trammell method, are there any kind of ellipses are there? Can you tell me? Eccentricity is there, concentric circles is there, pin string method is there, oblong method is there, and Trammell's Archimedes principle is there. There is a very most important method that is called it as hypotrochoid of 2C couple. Hypotrochoid of 2C couple. Okay, what is this? I will tell you in rollets, not in ellipse. Please don't forget this. Please make a note of it. I can explain you these things in rollets. I mean cycloids and involutes, not here. If I explain you here, you won't understand. Okay, but the thing is, hypotrochoid of 2C couple is also a kind of elliptical curve. Okay, so you please better have in mind of it. First thing is eccentricity method, concentric circles method, pin string method, oblong method. Okay, next Trammell method, next hypotrochoid of 2C couple. Okay, who proposed all these things? This concentric circles method was invented by Mr. Delahaye. And next pin string method, it's Gardner's method. Next oblong, the name itself is a person's, a scientist name, oblong method. Next Trammell of Archimedes. Next hypotrochoid of 2C couple. Okay, so please mind over it. Okay, we are not going to draw any method, any ellipse or any kind of curvature in examination, but they will ask you questions. How they will ask you questions, I will let you know. Okay, to tell you one thing. The next thing is arcs of circles method. Arcs of circles method, and this oblong method was introduced by Mr. Steiner. Steiner, Mr. Steiner. Okay, this is oblong method and this is arcs of circles method. In arcs of circles method, it strictly follows the principle of Pf1 plus Pf2 is equals to constant, that is equal to largest conjugate axis. It strictly follows that particular principle. Pf1 plus Pf2 is equal to constant, that is equals to largest conjugate axis on the particular ellipse. Okay, so this is about ellipse and how to draw all these things. Okay, now you got to know about how to draw all these things. Okay, so I will give you all the methods, all the methods description in all the methods links in description. Okay, you can okay, so now we will see methods of parabola and methods of hyperbola. Okay, in methods of parabola we have different types. One is oblong method, okay, in this oblong method when you will draw this parabola means, of course in parabola also the eccentricity method is there. This is common, V and F will be there, and this is how the parabola goes. Okay, this is what parabola. Okay, so here the VF and the VO, VF by VO is equals to 1. Why? Because of VF is equal to VO for parabola in eccentricity method. Okay, so the main thing is oblong method. When you will draw oblong method, whenever the span and range are given. Span means the length, range means the highest altitude. Whenever the span and the height is given, then you can use oblong method to draw parabola. Okay, here also there are certain limitations. Suppose a stone is thrown on a horizontal plane, then you can use oblong method. In oblong method there are two types. The first one is rectangular method. You have to use, you should use rectangular method. Okay, so next, so when the parallelogram method will come? Why? Because of there are two methods. One is rectangular method and another one is parallelogram method. So when you have to draw parallelogram method, the same stone is thrown from a inclined horizontal plane, from an inclined horizontal plane. Okay, inclined horizontal plane means you can, like this angle will be taken. Okay, so how it will be, how we have to draw parallelogram, parabola by parallelogram method, and I will give you the link in the description. Okay, so when the stone is thrown from an inclined horizontal plane, then you have to go for parallelogram method. Okay, and next one is tangents method. When the tangents method is, when you have to draw tangents method, same stone or same object, but he will give you the projectile angle. What it is? The projectile angle, not the horizontal plane. He will be standing in horizontal plane only, but he will throw the stone with some certain angle. Okay, when that angle is given, you have to draw parabola by tangents method. How it looks like is like this. This is the angle of projectile, this is the horizontal plane, and this is the range. On this range, what we have to do is, we will draw like this. Okay, and in between you will draw a parabola like this. This is how tangents method looks like. I will give you that description in the link. Okay, this is about parabola, and another one is there, that is offset method. That is offset method, when it follows the y square is equal to 4ax principle. This is the characteristics of, okay, y square is equal to 4ax. Okay, next, hyperbola. How to draw this hyperbola? What are the important things in hyperbola? What are the important methods? In hyperbola also, the eccentricity method is main. View E value, the value of E, and in E value you have to draw two hyperbolas will be there. Here it will be V1, here it will be V2, and this will be the F1 and this will be the F2. And we already come across with why this F1 cross this V1. Why? Because of for ellipse and parabola, F1 will be here, right side of the vertices. Okay, but here it is here. Why it came outside, I already told you. Okay, so this is eccentricity method. In eccentricity method, how you will draw is same. You will be given transverse axis. When there is transverse axis, okay, when the transverse axis is given, you have to draw eccentricity method. And what are those other methods? Next one is most important, asymptotes method. The most important is asymptotes method. Okay, asymptotes method means first of all, let me tell you what are these asymptotes. Okay, for parabola also it will be there, for hyperbola also it will be there. So what are these asymptotes? Suppose this is the hyperbola. Asymptotes are the tangents. Asymptotes are the tangents drawn on the hyperbola to meet the curvature at infinity. Okay, these are nothing but the tangents which are drawn on hyperbola to meet at. Tangent means, suppose tangent means if it is a circle, tangent should meet the circle. Okay, but here asymptotes will not meet. Of course it will meet, they will meet, but where? At infinity. These are the tangents. These are the tangents drawn at infinity. Okay, asymptote 1 and this is at asymptote 2. Okay, so these are the tangents. Okay, here they will not meet, they will meet at infinity. Infinity means you cannot see, I cannot see. Okay, so this is tangents method. This is asymptotes method. In asymptotes method, what is asymptote? Tangents that are drawn on the hyperbola to meet the curvature at infinity. Okay, in asymptotes method, the nature of the curvature will depends upon the angle between asymptotes. So drawing hyperbola by asymptotes method looks like this. Okay, here the angle is 90 degrees. Okay, if the angle is acute angle, then the curvature will get shrink. If the angle is obtuse, the curvature will be little bit like this. Okay, so the nature of the curvature depends upon the angle between the asymptotes. Usually it will be 90 degrees, but sometimes it may change. Next one is arcs of circles. Not only arcs of circles method, intersecting arcs method. Both are same. Arcs of circles method or the intersecting arcs method, both are same. When you have to draw hyperbola by using arcs of circles method, when the characteristic of the curvature is given, like for this parabola y square is equal to 4ax, and like that for the ellipse it is pf1 plus pf2 is equal to constant, and for hyperbola it's pf1 minus pf2 is equals to constant. Okay, then you have to use hyperbola by asymptotes method, and especially this hyperbola follows the Boyle's law. PV is equals to constant. Only hyperbola will follows Boyle's law principle. PV is equal to constant.